Hey everyone. So today we're going to see about what is conditional probability and what is the use of it and how do we use it. But before we gonna know about what is the conditional probability, so let's get started. So we all are very well known about the probability, and if you don't know about it, then it's the concept of it just need and need to know what's the probability if you don't know it. But yeah, let's get started with our main content, which is the conditional probability. Okay, what is conditional probability? But first, we need to know about what is the condition in it. Okay, so as we know, the probability. What is the probability tell us? Happening of an uncertainty or of an event that is going to happen. Okay, so what is condition then? So the condition, this term actually this telling us that we have some certain conditions, and according to that condition, we have to find a probability of an event that it is happening based on some conditions. Okay, so if we take an example, then let's suppose that you have a condition first that that you have to make some homework. Okay, if you take an example that you have to complete your homework, then you need first condition you should be completed, that is you have to attend your class. If you wouldn't have attended your class, how the hell you could get your homework? Okay, so it is one of the condition. Of course there are a lot of condition in the daily life hour also that we use, is that if this condition happens, or if this condition has been done, then we can do some other thing. Okay, then we can do some another thing. Yeah, so this is what happens in the condition. And this condition are actually that if one event has happened in the term of probability, what we are saying actually is that if one event has happened, then what is the probability of the second event happening after the first event? Okay, so yeah, this is simple. We will keep it very simple. Okay, so let's understand via diagram. Okay, so we have actually two events here. Okay, the first is A and the second is B. Okay, and so if we have to find the probability of A, that what is the probability of ev- event of A happening, then what? How do we calculate it actually in our like classic style? So probability of A. Okay, then we have what we do actually, that A by the whole sample. Okay, what's the whole sample? This box. Okay, this box. This box is the whole sample actually. So A plus B or whatever this box will get by box. So we box. Okay. So this is the our simple probability of A. Okay, the simple probability of A. But now the case here actually is that we have to find the probability of either of a event, either of a event in which one has already occurred. Okay, one has already occurred. So in the case, what we do actually this, B has if event B has already occurred, then what is the probability of event B happening again? Okay, so what is the probability of A happening after the event of B? Okay, this is the case. Okay, so and and one of the most important thing is the conditional probability. If you understand this, then you're going to understand the whole conditional probability. I'm going to tell you that the sample space, the sample space uses whenever an event occurs. Okay. The sample space reduces how? Okay, see, we had to find the probability of A. We have to find the probability of event A occurring. Okay. So whenever the event A occurs, we had the sample of the whole box. Okay, whole box, our whole box was the sample. Okay, and we could find the probability of A using the whole box. But the case here is the condition we have said to this, that if this condition applied to this, the condition applied to this, that if wait, yeah, okay, that B has already occurred. B has already occurred. So our sample reduces from this box to this only to B. Okay, only to B. We have our sample space to B. So we're not gonna use A. Okay, the whole box, sorry. The whole box. We're not gonna use the our whole sample, which is the box. Okay, which is the box. We are gonna only use B. And this is the most important thing. Okay, and this is the most important thing. If you understand this, okay, wait, something happened. Yeah. Okay. If you understand this, the if the sample space reduces to an that event only that has already occurred, you're gonna understand the whole conditional probability that if a, an event has happened, then the sample space becomes that event only. Okay. Here is the formula of it. The probability of A given B has already occurred. Okay, there are some symbols that probability. There is a event A, there is a event B, and this pipe. Okay, so this pipe, or what do we say? This pipe actually, yeah. So this pipe actually is telling us that probability of A given B has already occurred. Okay, so we have to find the probability of A if B has already occurred. So what we know that, what we have said actually from this term, that the sample space reduces whenever an event occurs. Okay, so B has already occurred. We have know that B has already occurred. So what is the probability of A? So what we are doing actually, B has already occurred. We know that B has already occurred. Now B has already occurred. So the sample space we have left only is this B. Okay, we don't have the sample space of the whole box. We have the sample space left only is this B. Okay, and the favorable outcome we have actually is this part. Is this part? Is this part? Actually, this part. So this is our favorable outcome because in which B A has to already A has to occur also, but it cannot because the sample space has reduced to B. That's why the sample space had reduced to B. That's why, and this is the A intersection B. So this is actual. We will find our probability of a applied condition. Okay. Yeah. Okay. Of an condition. Why is this? But wait. Yeah. So this condition, which is the probability of A, okay, the probability of A given that B has already occurred is going to be probability of A intersection B. Avoid my writing, but then the probability of B. Yes. Now we could find the probability if we have given the data. We can find the probability of if we have the data. So let's suppose. Sorry. Let's suppose if we, in the box we had like 10. We have 10 outcome, okay, and the favorable outcome for us actually will be this is the probability of the ignore my handwriting. This is the whole sample and the probability. Then the favorable outcome for us is 5. Okay, so 5 by 10 is nothing but 1 by 2, which is nothing but zero point 0.5, which is zero point 0.5. This is the probability of B. Okay, this is what, this is actually the probability of B. Okay, and this intersection A intersection B, this thing, this intersection A intersection B, which is nothing. If suppose that it is 1, okay, it is 1, and we had the probability 0.5. Okay, this is not actually 1 because like you cannot have the probability of, but yeah, let's suppose I'm taking it wrong. But suppose that the intersection would be some number. Okay, I don't have the correct example right now, otherwise I would tell you. But yeah, something it is. Then the probability of B will be in the denominator and the probability of A intersection B. Okay, and this is our conditional probability. Okay, yeah, this is our conditional probability.